students. I am Pragati, lecturer in chemistry in Shakthi PU College, Mangalore. Today I am going to discuss about one of the topic related to general principles and process of isolation of elements. So today we are going to discuss mainly of one of the extraction process from this chapter. So we all know that main process for the extraction, the availability of the metal. So we need to know that where these metals are available. Especially the source of these metals are the minerals. So minerals are the chemical substances which are available in the earth crust. So we are going to discuss about one of the important and interesting topics, how the extraction of the metal can be processed. So before that, we need to have some of the knowledge regarding it. So what are the steps are involved during this process? So now we are going to discuss about this topic. So here you can see a metallurgy. It's written over there, that is metallurgy. So what is metallurgy? So why these principles are important to carry out for the extraction process? So metallurgy is a process which is of dealing with entire scientific and technological process for the extraction of the metal from its ore. So there are several steps has to be taken place. It involves scientific and technological knowledge so that we are going to get the pure metal at the end. So these steps will be taking place in three major steps that we'll discuss later on. So now we have understood what is metallurgy. Then, so what are some of the important terminologies we need to know? So as I mentioned earlier, we need to know about what is mineral, what is ore, and what is gangue or matrix. So you know that minerals are the chemical substances which are available in the earth crust. The main source of metals are minerals and the ore. So minerals are the chemical substances from which the metals are extracted. Then what about ore? Ores are nothing but these are the minerals from which the metals are extracted conveniently and economically. Because we know that so ores possessing metals which are of highly economically important. Then what about this gangue or matrix? So the gangue or matrix are nothing but these are the impurities which is associated with the ore. So we are looking for the pure metals at the end. So we need to remove this gangue and matrix in terms of chemical treatment. Now what are the major steps which has to be involved to get the final product that is of our interest, that is a metal? So there are three important steps which has to be taken, and it has to be considered as a stepwise process. The first one, that is a concentration of ore. So what do you mean by concentration of ore? Concentration of ore is nothing but we are going to remove the unnecessary unwanted particles from the ore, so that we are going to get end product as what we are looking for, that is the pure metal. So concentration of ore can be variable to one ore to the other, because the metal which possesses, they will be having some own properties. So all the metal has to be made into a separate, with the proper shape or desired size, so that they can be proceeded into the second step. So second step, what we are looking, that is of isolation of metal from concentrated ore. So this isolation of metal from the concentrated ore has to be taken care in two different steps. That is, initially we have to convert ore into a oxide. Later, the reduction of the ore will take place. So, conversion of the ore to oxide has been taken place in two different methods, that is of calcination and then roasting. So what do you mean by calcination and what do you mean by roasting? These are the two important definitions, as well as very important process which has to be taken place during the second step of the process. So calcination is a process of conversion of ore to particular oxide. So the calcination is nothing but heating the ore in the absence of air or limited supply of air. That is nothing but the calcination. Some metal has to be undergoing the calcination process. We know that all the metal will not possess a similar properties, and also they will be present in terms of different composition. So some of the metals can be considered to be undergoing calcination, and some of the metal will undergo roasting. So what is the meaning of roasting? Roasting is a process of heating the ore at high temperature in the presence of high amount of the oxygen. That means you need to apply a sufficient amount of oxygen. And specifically, this roasting process will take place in a reverberatory furnace or the blast furnace. So, blast furnace and reverberatory furnace is a chamber in which the reaction takes place at the different temperature gradient. So, extraction of the metals will variable from metal to metal. So, we are going to discuss among the variable metal extraction, we are going to discuss one of the important extraction process. And finally, the third step, that is of purification of metal. So it is an end process which has to be taken place. So this purification of metal is nothing but the refining process. So it has to be done so that we are going to get a desired product at the end. So you know that these metals are economically very important, and it also plays important role in our day-to-day life. So now I'm going to discuss about one of the extraction process that is of very important. So that step is nothing but the second step in which the extraction of the metal takes place. So one example I have taken, so we will discuss about it. So specifically, I'm going to discuss about extraction of iron from its oxide. So how the extraction of the iron from its oxide can be carried out. Specifically, extraction of iron from its oxide has to be taken place in a blast furnace. So you can have a look on here the diagrammatic representation of the blast furnace. So you can observe how the representation of blast furnace is given. So initially you can observe the body of this furnace is made up of steel body. It is made up of steel. And then it is, you can observe there is a different temperature gradient. You can observe there is a different temperature gradient. So it has to be protected by using a lining of fire bricks, which will act as a protective barrier to this reaction, because this reaction is taking place at a different elevated temperatures. So we need to take care of this furnace also. And then by considering a fire bricks, so that the reaction will take place in a orderly manner. Then, so you can see some of the outlets here. So there is initially you will be going to draw the composition, that is iron oxide. It can be of oxides of ions, it can be of hematite, or it can be of magnetite. So hematite is nothing but Fe2O3 and magnetite is nothing but Fe3O4. It will be dropped from the top. Along with there will be two more composition which has to be added. So that is nothing but the coke, that is carbon, and the limestone, that is calcium carbonate. So these three mixture will be taken and it has to be fed from the top of the blast furnace. So later on you can have a look on here, and there is simultaneously that you need to add or you need to pass a blast of air with the pressure, and you have to transfer oxygen from this end. So there will be a reaction with this composition, and then whatever the exhaust gas which will be produced, that will be eliminated from this end. So that can be of carbon monoxide or it can be of carbon dioxide. Simultaneously at the end you will be going to get a slag. The slag is the product which is formed at the end of this reaction when the impurities are removed. When the impurities reacts with the flux, that results in the formation of the slag. And then at the end product, what we are looking for, that is a molten iron which is formed at the end. So that can be removed by collecting separately. So then this is explanation regarding how the blast furnace is made up of. Then we will see what is the reaction is happening in this blast furnace. First of all, we need to take a mixture of the compositions. That is nothing but the oxides of iron. So this oxides of ions can be of Fe2O3, that is nothing but hematite, or it can be of Fe3O4, that can be of magnetite. So oxides of iron along with a mixture of limestone and coke will be added from the top of the blast furnace. So what happens when you transfer the mixture of this iron oxide, coke and limestone from the top of the blast furnace? Initially we need to add oxides of iron which is obtained after the concentration process. You know that concentration is the process where you are removing impurities. Along with that impurities, you will be removing moisture, that is water molecule will be removed. So carbonates will be decomposed and there will be a oxidizing of sulfide. So that will be removed as a sulfur dioxide, because we are interested only in oxides products, so which is obtained after the concentration of ore. And this is the second step of the metallurgy, so extraction process. So the product which is obtained at oxides of iron which is obtained from the concentrated ore. So along with oxides of iron and along with limestone and the coke is fed from the top of the blast furnace. There will be a reduction process which will take place at different temperature gradient. You can observe there is a decreased temperature gradient as you move along the blast furnace. Then what happens, what is the reaction will be taking place in this process? So you know that the process will take place at the different temperature gradient. So when there is a supply of hot air from the bottom of the blast furnace, this end you are going to supply a hot air. So there will be a presence of coke, that is a carbon. The reaction takes place between the carbon and the blast of air that results in the formation of carbon monoxide. That carbon monoxide will give you the atmosphere of high temperature range at the bottom of the blast furnace. This temperature gradient is obtained when the reaction taking place between the coke as well as the oxygen. So this region will be having higher temperature around 2200 Kelvin. So you can observe higher temperature gradient will be observed in this portion. So what is the reaction is happening? What is the reaction is happening here? So as I mentioned, when the coke, that is a carbon, when it is made to react with the oxygen, results in the formation of carbon monoxide. So this carbon monoxide will produces heat. It produces heats and move along the blast furnace. Here you can observe there is a increased temperature gradient which is observed in the bottom of the blast furnace, which is resulted by the reaction of coke along with the oxygen. So this is what happening in this region. You can observe 2200 Kelvin temperature, that is the highest temperature which is observed. Then this provides a different temperature zone. So there will be a different reaction will take place at the different temperature zones. Now we will study about the reaction which is taking place at 500 to 800 Kelvin temperature. So this temperature range is considered to be a lower temperature range. So what are the possible reactions are taking place at this particular temperature range between 500 to 800 Kelvin temperature? As we all know that Fe2O3, when it is made to react with the carbon monoxide which is produced by the initial reaction to form a product that is Fe3O4 plus carbon dioxide. There is also a presence of Fe2O4, that is oxide of iron, when it is made to react with the carbon monoxide that results in the formation of the iron, and then along with that you are going to get a carbon dioxide. So even when there is a presence of Fe2O3 that also reacts with the carbon monoxide at a given temperature range to form a product iron oxide along with the carbon dioxide. So these are the three steps of reaction which can be observed in this particular temperature range, that is of 500 to 800 Kelvin temperature. Then what happens at the high temperature gradient? So at high temperature gradients is considered to be of 900 to 1500 Kelvin temperature. So what is the reaction is happening at this temperature? The reaction taking place between the coke, that is a carbon, with the carbon dioxide which is produced in the initial steps to form a carbon monoxide. So carbon monoxide is formed by the reaction of carbon. When it is made to react with the carbon dioxide, it results in the formation of the carbon monoxide. Later on, whatever the product is formed, that is FeO, that is iron oxide which is formed by the initial step, when it is made to react with the produced carbon monoxide, results in the formation of the product that is Fe, that is our interest, which will be present in terms of molten state. along with that carbon dioxide which is formed, which will be eliminated at the top of the blast furnace as the exhaust gas. So this iron which is formed, which will be present in terms of molten state, because we all know that the process has been taken place at a different temperature range, so the metal will be present in terms of the molten state. These are the different steps which has been observed during the reaction which is taking place in the blast furnace. So this is one of the important extraction process, especially of we are talking about the iron. So there are different extraction process which can be carried out for specific metals. It won't remain same for all the metal extraction process. So metals are specified in its properties in terms of chemical reactivity or in terms of physical properties. So we have to consider these properties, then we have to carry out this process so that we will get the pure product at the end. As I mentioned earlier, the extraction process will be of second step which will be taking place in the metallurgical process. The final step will be a purification of the metal. So that is the end step which will be carried out so that we are going to get the pure metal at the end. Several metals can be obtained by this metallurgical process, especially of iron, copper, nickel, zirconium, titanium, gold, silver. So these are all the important metals which can be extracted by using metallurgical process. After the reaction which has been taken place at different temperature gradient, and you know that there will be also impurities which is associated with the iron oxide. So that also has to be removed. From the top of the blast furnace, we have added three composition, that is of iron oxide, limestone, that is nothing but calcium carbonate, and the coke, that is carbon. So what is the role of this limestone then? So this limestone, which will undergo decomposition, results in the formation of calcium oxide and the carbon dioxide. So the role of this limestone, where it undergo decomposition, that is nothing but calcium carbonate, will undergo decomposition at a temperature, the given temperature, so that it results in the formation of calcium oxide. Along with that, you are going to get carbon dioxide. So you know that the metal ore possessing a impurity which has to be removed so that we are going to get a desired product. So this calcium oxide which is formed by the decomposition of calcium carbonate results in the reaction with the impurities which is present, that is of silicon dioxide. When the reaction is carried out between calcium oxide with the silicon dioxide which is present in terms of impurity, results in the formation of calcium silicate, that is CaSiO3. So the product, that is calcium oxide, which is formed is nothing but the flux. So that reacts with the impurity, that is also known as matrix, or also you can term it as gang. So silicon dioxide which is present along with the iron oxide as a impurity. So silicon dioxide is an impurity which has to be removed so that the flux will undergo reaction with the silica to form a product calcium silicate. So SiO2 is also termed as silica. So this silica is present in terms of impurity. So it will be removed at this step. So at the end you can observe the product, that is calcium silicate, which is nothing but the slag. So there will be results in the formation of the two layers. So there will be a two layer molten slag as well as the molten metal. So molten slag will be eliminated at one end of the blast furnace. At another opposite end, you will get the product, that is molten iron. The two layers then separated, and then we can separate the product what we are desired to look for. So there will be a two layers, that is molten slag layer as well as a molten metal layer. So molten layer can be separated, and then we can separate a product what we are looking for. The extraction process will be a specific for specific metals. So there are many economically important metals so which can be considered to undergo metallurgical process, especially of iron, copper, nickel, zirconium, titanium, gold and silver. So these are the metals can be considered to undergo metallurgical process. There are many more, but then you will be studying about some extraction process which is relevant to this topic. So today we have studied about some of the important concepts related to general principles and isolation of metals from the elements. So we have studied a basics knowledge about the metallurgical process, so especially of one of the extraction process involved in extraction of iron from its oxide. Thank you.